Hello everyone. Before starting the next lesson, please try this warm-up. Complete the table. X for X. So figure out what numbers to put in these spots. Pause the video, try this, and then check back in to see how you did. Here are the answers. X has a value of 1. 4x means 4 times x. So if x has a value of 1, then 4x would be 4 times 1, which is 4. Now we change the value of x to 2. 4 times 2, 8. 3, 4 times 3, that's 12, etc. So hopefully you figured that out. This is important as we move on to the next lesson. We've been talking about functions as machines and functions and tables, functions and mapping diagrams. In this lesson, we are looking at functions and algebra. So we still need to know what a function is, and we're going to use some algebra to figure out what the output is for any input in the function. We're going to use equations in function notation to represent linear functions. So we'll talk more about that through the lesson. In the past, we've talked about input and output when it comes to functions. And we're going to start using some algebraic notation here. So instead of writing the word input, we're going to symbolize that with an x. X represents whatever the input is. Now the output in this table is 4x. So this actually shows us the rule of the function as well. To get the output, we multiply the input by 4. We can also take this table and list the ordered pairs. This is something we did in a previous lesson. For example, when the input is 1, the output is 4. So that's an ordered pair of 1, 4. And we can make the ordered pairs for the rest. Now this idea is going to come into play later when we start graphing, but for now, just know how to find an ordered pair from an input-output table. Now, is this a function table? Do you remember how to find that out? Remember, in order to be a function, there has to be only one output for every input. So if we look at each input, how many outputs are there? Well, only one each. So yes, this is a function table. Now, every function has a rule, so what is the function rule in this case? We can look here. To get the output, we multiply the input by 4. That is the rule. Now, mathematicians usually use x for the input and y for the output of any relation. So when we look at our input-output table, we can call the input x and we can call the output y. Now we can write an equation for the output. In this case, it would be y is equal to 4x, 4 multiplied by the input. So we're just rewriting the rule of the function as an equation. Now, if a relation is a function, mathematicians use what we call function notation, and this is what function notation looks like. The way we pronounce this is f of x equals 4x. Now, the f is the name of the function. We're calling this function f, f for function. That's usually what we use in the general form, but you can use any letter you want as the name of the function. If it's a height function, to calculate height, you can use an h. If it's distance, you can use a d, whatever letter you want. Usually I'll use an f, just f for function. In brackets, it's whatever the input is. In most cases, we're just going to say the input is x. So f of x, the function of x, equals this. This is the function rule, 4 times x. Now notice here, x is the input. X means the same thing over here, 4 times x. So instead of writing y equals 4x, we can write that in function notation, f of x equals 4x. For the function rule, write an equation in terms of the input variable x using function notation. So the first rule is add 5, and I want you to figure out how to write this as an equation in function notation, f of x. So you will have f of x equals, and then your rule. Do that for each different rule, and if you want to try the bonus, you can try the bonus. Pause the video, try this, and see how you do. Here's the first one. The rule was add 5. So the function of x as the input is the input plus 5. Input, and we add 5. That's where the equation came from. And maybe you had trouble just with the first one, but now that you've seen this, you get the idea, so you can pause the video and try the rest. The rule is subtract 3, so input minus 3, x minus 3. The next one, multiply by 2, so you're multiplying x by 2, 2x. And we're writing this in function notations with f of x equals in each case. For the bonus, multiply by 3, then subtract 1. So f of x is equal to 3x minus 1. Multiply by 3 and then subtract 1. If you're having trouble with this idea, I would recommend you pause the video and get some help before you move on to the rest of the lesson. In this question, I'm giving you the function equation in each case, and I would like you to calculate what the output values are for all these different input values. I'll get you started with the first one. The function output is 3 times the input minus 1. So if the input is 1, that goes here. 3 times 1, that's 3. Then we subtract 1. The answer is 2. And then you move on. Now the input is 2. 3 times 2. That's 6 minus 1. That's 5. See if you can complete the rest and complete the other function tables. Pause the video, finish this off, and see how you did. And here we are. If you had any issues with these, you should ask for help before you move on. Function notation can be used to show the output value for any input value. So for example, f of x is the function in general. So here's my equation. F of x is equal to 3x plus 1. But I can be more specific. F of 1 is the output of the function when the input is 1. So I would write that as not f of x, but f of 1. The function when the input is 1 is equal to 3 times 1 plus 1. So I can calculate what that's equal to. I just follow the order of operations like before. 3 times 1 is 3, and then we add 1, that's 4. So f of x is the general equation. F of 1 is the specific output when the input is 1. Likewise, when I write f of 2, that means I'm finding the output when input is 2. So f of 2 is equal to 3 times 2 plus 1. I can work it out. The output is 7 when the input is 2. This is how we can read function notation. F of x is the function when the input is x. If you see a number in the brackets, that just means we now have a value for our input and we can calculate what our output is. So I'd like you to try this question on your own. Calculate the values for the function f of x equals 5x minus 2. So you have your equation. I'd like you to calculate f of 3, f of 10, and f of negative 5. Use what you learned on the previous slide and apply it here. Pause the video and try this on your own. F of 3, we replace x with 3, so it's 5 times 3 minus 2. 5 times 3 is 15, minus 2 is 13. every time we replace x with whatever the input value is, and we do the calculation. If you have questions about this, please reach out before you move on. Now here's a quick recap of everything we've talked about as far as how to represent a function so far. We've represented functions as a machine where we have input x, output y, the rule in the machine. We can represent that same function with a table. So for different input values and the rule of doubling the input, we get the different outputs. We can represent that as an equation using function notation. So if the rule is that we're doubling the input, 2 times x, or 2x is the equation. We can represent this table of values as a set of ordered pairs or as a mapping diagram. All these different ways of representing functions are valid, and they are all different ways to do it. But there's another way we can represent a function, and that is with a graph. And we're going to start with an easy way to make a graph of any function. First step, make a table. So if you know the equation of your function, we can make a table of values. And then once we have a table of values, we can turn it into a list of ordered pairs. And we can graph the set of ordered pairs. And once we have our ordered pairs, we can connect the dots and we have a nice graph of our function. So our function was f of x equals 2x plus 1. I'm going to make a table of values, and I can choose whatever x values I want. I'm just choosing 1, 2, 3, 4, and 5. For each different input, I can calculate what the output would be using the rule of the function, 2x plus 1. And I would get these values as my output values. All right, the next step is to turn the table into a set of ordered pairs. So I just took my x and y values and wrote them as x and y coordinates. So when I have a point 1, 3 on my graph, that's when x is 1, y is 3. The point goes here. Next, 2, 5. When x is 2, y is 5. That goes here. 3, 7. When x is 3, y is 7. And I can keep going. And once I've plotted all these points, or my list of ordered pairs, I now see that these points are following a line, so I can just keep that pattern going and connect the dots. And I get a graph of my function. So the function f of x equals 2x plus 1 looks like this blue line when we graph it. And now I'd like you to try doing this with different functions. Make a function table, so you can use this as a template to do your own work. Make a function table and then write the ordered pairs, then plot the ordered pairs on a graph. So you're going to do what I did on the previous slide, and you're going to make a table of values using your function and then turn that into a graph. Pause the video and try this, and then you can check back in to see how you did. Here's the first one. Now we can check the next one. And this next one, well, this point doesn't fit on my grid, but you get the idea. It's not a straight line this time, it kind of curves. And if you tried the bonus, this is what we would get, another curve. I want to switch gears a little bit here. I want to talk about gaps. So here's an example of a function table. I know it's a function table because each input has exactly one output. 3x plus 4 is the rule of the function. Now the word gaps here, this is what I'm talking about. When I look at the output values, how much are they changing by, or what is the gap in between each successive output value? From 7 to 10, we're going up 3. From 10 to 13, we're going up 3, then up 3, then up 3. So I can visualize the gaps like this. You might have heard them called something else. We call these the differences. But this is what I'm referring to when I talk about the gaps. It's the gaps between successive output values. So for each of these functions, I would like you to create a function table and then find the gap. Pause the video and make your function tables, find the gaps, and then check back in to see how you did. Okay, here's what we get. And I noticed that the gap is 3 in the first function, and the gap is 0.5 or half, 1 over 2, in the second function. So a follow-up question now is, how is the gap in y reflected in the expression? Well, this is what I want you to notice. In the function expression here, the coefficient on the x variable is the same as the gap, and it's the same in the other function too. 1 over 2 is a half, that's 0.5, and that's what the gap was. And that's always going to be the case. If you have a function with a variable that's just x and no other x variables, the coefficient on that term is going to be the gap in between your successive y values. And this can help us when we make graphs. So when we see a graph of a sequence of ordered pairs like this, we can identify what the gap is. And that can help us figure out what the equation of that function is going to be. Visually, you can think of the gap as the steps to go from one point to the next on the graph. As you move over 1 unit in the input, you go up 1 unit on the output. So the gap is 1 in this function, whereas the gap is 2 in this function. So here's an example of a function that I've put ordered pairs on the graph of, and I want to figure out which of these equations will model the function. So I can use that idea of what is the gap to figure this out. If I look at from one point to the next, I'm going up 3 every time. So because my gap is 3, I have to find the function equation that would have a gap of 3. Remember, I'm looking at the coefficient in front of the x variable. Right here, because that is 3, I know that this is the function that matches the graph. Now we talked about a lot in this lesson, talked about functions and function notation and how to read function notation. And we looked at how the function equation relates to a graph in terms of the gap between points. You put all that together in this practice sheet. So you need to practice this in order to get used to this idea of functions in algebra. So as you're practicing, if you have questions, please let me know.